Carboxylic acids and esters are usually considered together because their functional groups are closely related. Esters can be made from carboxylic acids and vice versa. If a carboxylic acid dissolves in water, it can weakly ionize to give a solution with an acidic pH, and of course, then it is a weak electrolyte. Carboxylic acids will also react with bases in neutralization reactions as seen below. The sodium hydroxide is basic and can pull off a hydrogen from the carboxylic acid, resulting in the sodium salt. Carboxylic acids can react with alcohols and an acid catalyst to form esters while releasing water. Esters can undergo hydrolysis, adding water to the ester linkage, breaking it apart so that the carboxylic acid and the alcohol are formed. Saponification also breaks apart an ester linkage, but the catalyst is a base. There is an intermediate step before the complete carboxylic acid is reached. The alcohol is formed during the reaction, but the acid is formed as the anion, which is soluble in the water solution of the reaction. To obtain the carboxylic acid back, this needs to be precipitated using HCl. The carboxylic acid is usually insoluble. In the hood, add 2 ml of water and 10 drops of glacial acetic acid to a clean test tube. Note the odor by wafting. Take a glass stir rod and dip it into the solution. Touch the stir rod to a strip of pH paper and record the pH. Now add 2 milliliters of 2 molar sodium hydroxide to the solution and stir well to mix. Determine the pH. Waft the solution and note the odor. Carefully add 3 molar hydrochloric acid to the solution. Record the pH. Place 0.1 grams of benzoic acid to a test tube. And add 2 milliliters of water. Stir well. Add to this solution a drop of 6 molar sodium hydroxide and stir. Continue adding and observe until all the benzoic acid has dissolved.